So again, I'd like to thank Ms. John for inviting us in. When I say us, for myself and some of the other parents who are taking time out of their day to meet with you. And I think we'll all learn something. I'm as interested in what you guys are doing and what you're learning as maybe, hopefully, what I'll talk about today with you people. Who am I? We'll talk about who I am and what I do for a living, and again, some helpful tips on what I find helpful in problem solving. So, I'm Mr. Ellis. I'm Peter Ellis's dad. Stand up, please. I'm an advanced process control engineer. It sounds like a lot of alphabet soup, but I'm an engineer, and advanced process control, that's abbreviated as APC. Okay, so I'll be saying APC Engineer all the time. That's what I do for a living. I went to the University of Wisconsin for a bachelor's degree, and I went back to, I worked for about 7 or 8 years, went back to school to get a master's degree, and to get to Texas as soon as I could. Okay. I work for a company called, I'm a senior consultant, means I'm old, and I work for Applied Manufacturing Technologies, and that's a company that's based out of Houston, right at Willcrest in Richmond is our office. We're a worldwide company. There's about 35 of us engineers that work all around the world. Europe, we got guys in Japan, Korea. We stay pretty busy. Okay, so advanced process control. You guys have no idea what that is, okay? I had no idea what it was when I was in high school or even before. So what is process control? And, well, it's taking showers, right? No. This is the classic example when I have to explain what process control is. This is the perfect example, okay? It's the shower example. You manipulate hot and cold water to control the water temperature and flow, right? Every time you get in the shower, if it's too hot, more cold. If it's coming out too fast, you turn it down. The person in the shower measures the temperature of the water and the flow rate based on their comfort level, right? And whoever's taking the shower adjusts the hot and cold to get the water just right, okay? So, what is process control and what is a controller? Well, when you take a shower, you're the controller. Jump in the shower, and especially now, it's really cold outside. So you jump in the shower, and it's like, holy cow, this is cold. So you turn up the hot water. And then your sister or brother jumps in the other shower in the house or flushes the toilet, and all of a sudden the water's cold, and you gotta adjust the temperature again. Alright? You do it every day. That's process control in the simplest form. So what do I do? What is an APC engineer? We use computers, engineering skills, our problem-solving abilities. Problem-solving, keep that in mind. That's very important. To make industrial processes safer, more environmentally friendly, more profit. I work in refineries, chemical plants, and process facilities all over the world. Lots of refineries. You've all driven to Galveston. You drive by Texas City, you see all those refineries. Go ahead.
I see them. I saw it in summer once when we were going to see my family. I saw that.
Yeah.
And then my family said that caused pollution.
That's right. Well, it does and it doesn't. Over the past 15, 20 years, the amount of pollution those refineries have put out has been cut almost to nothing compared to what it used to be. But anytime you make something, you're going to cause some pollution. You got up and got ready for school today. You took a shower, you ate, you did all kinds of things, and you affected your environment. Right? So anyway, so we've all seen refineries. Do you ever wonder what goes on inside those refineries? I mean, they're huge, right? They look like huge cities. So within those refineries and plants, there's separate processing units. Okay, and that's a nice clear day. Refinery, just like the ones down in Texas City. Controller that controls what you're trying to do, but you also have to explain it to the guy who has to control. He has to sit at the computer and use your program. But you also have to explain it to the refinery manager. So not only do you have to know your job well, but you have to tell the other people and explain to them what you're doing and what the controller's doing. So what does that look like to you here? What does that look like to you guys? Exactly. Not too different than what you guys are sitting in right now. This is the process operator control room in any refinery or chemical. People who run those big processing units sit at desks just like this. And you can see the big screens and all the technology we have. This is a picture of one particular unit that we worked on. That we draw this picture before we even start the work. Keep that in mind when we start talking about problem solving. Okay, and this is just a controller that I had built not too long ago. And it's just I wanted to show this to let you guys know that all this is a web page. So these people that are working in the chemical plants are looking at web pages and changing things just like a computer like this, no different. So we write programs that do things for our customers. We write programs that do things for us because we're kind of lazy. We want to have a program that does things faster so we can go home and spend time with our family. Okay, we're also very good. Have you ever heard the term bit flipper? A bit flipper? That's a programmer, sometimes called a bit flipper. Good at programming and coding. And we're really good problem solvers, and we're able to make things work. Starting chemical engineer, we'll make about $80,000 to $100,000 a year. And that's starting out. Maybe $70,000 to $80,000, $90,000 a year. That's a lot of money. Anyone else have any questions? Go ahead. I went to Texas Tech. No, my bachelor's was at University of Wisconsin, and then my master's degree was at Texas Tech. Well, I work for a company, and they hire us to work for them. So the Exxons and the Valeros and you name the company, I probably worked for them at one point. They hire us to help them. We have a very narrow. We're really good at this kind of stuff. So they hire us to help them. So solving difficult problems, solving hard problems is the best and worst part of my job. I love solving problems. But I also hate it. The best part of my job because it feels good to, when you solve a problem and you get it right or you do well in an exam, how that makes you feel. That's how I feel when I do a good job. Okay, when the controller's running and the operator's really happy and the refining manager comes up and says, "Good job," and shakes your hand. That's a good feeling, right? Also, they pay you a lot of money. If you can do anything really well, people will pay you money. That's good. It's hard to solve problems, right? You've all probably taken a test before where you looked at it and said, "Oh wow, I don't know what did they ask me to do?" Right? So often the problems I have are extremely hard to solve, and that can be frustrating. Good things and bad things about my job. Learning to code is hard. It was a lot harder when I was your age. Well, we never did it because we didn't have computers way back when. But learning to code is hard. It can be frustrating. Today, what I hope to teach you, one of the two things I teach you guys, is just how to be better problem solvers. All right? So when you're working on your code, or when you're working on a math problem, or when you're working on a project for social studies, maybe it won't take so long if you're a little bit better organized and better at solving problems. All right? And definitely will make you a better coder for sure. Here's a little cartoon. I love cartoons, and thanks to the internet, you can click and paste. And so what do you guys see here? So problem solving. What is the problem? You got 3 cavemen, right? So what's going on? Can someone explain to me? You.
Yeah. The cavemen are having rocks in the cart, but the wheels are square.
Yeah.
And the other caveman is going to them and telling them to put on these wheels, but they say no thanks.
Why does he want to put the other wheels on?
Because it will work much better and it will roll much better.
Exactly. How about you?
I thought, once I saw it, because I did not notice the square wheels,
yeah.
And I thought that he was standing on the one that said no thanks, I thought he was standing on these 2 lines.
Ah, okay.
And it looked like the guy in the first caveman, saying we're too busy, was pulling the rocks and the
So here's a case where, what's the problem? These guys can pull that, they can pull that cart full of rocks everywhere. They got square wheels and take more energy and it'll be harder, but there's no problem, right? Well, this other guy says, there's a problem. Out of these round wheels, it's going to work a lot better. Let's solve this problem. So that's kind of, and they're cavemen, which cavemen aren't supposed to be very smart, but the guy on the left's a pretty smart caveman, actually. So what kind of problems do you have in school?
Okay.
Like a computer program? What other sort of projects do you do in the other class? Anyone? Yes?
We're doing a science project now where we're doing alternative energy.
Yeah, exactly.
And we have to, we have choices, and people are choosing a choice, and what I'm doing is I'm going to build a model of solar.
Good. Yes?
Last one, we're going to take the no cars. 20 no cars.
Yes.
In fact, about alternative energy, resource, alternative energy. And this week, we're supposed to use these facts and write text, like make a diagram of those alternative energy.
Yeah? Okay, so you got a fun, sounds like, is that a science project, or?
Yeah.
Yep,
It's a science
5
project.
grades.
It's what?
5 grades.
5 grades. Ooh. Well, that sounds like a good project. It sounds like you really have to be organized, right? Huh? You have a plan? Okay. Anyone else? Or? Okay, so let's talk a little about solving problems, right? So this is a little a video that sometimes problems are really easy to solve. Identify the problem here and what would be your solutions?
You can walk up the
What is the problem, right? Go ahead.
They just stand
Why are they standing there?
because the escalators are moving.
That's right. Exactly.
Just walk up. What's the plan?
Go ahead.
For some reason, they didn't just walk upstairs.
That's right. So this is an easy problem to solve, but so what they could have done is just walked up the stairs, right, and then called the repairman or something like that. Maybe they didn't know any better. I would hope they did, but maybe they don't know. So this is a case where they have a problem and they're not really trying to solve the problem. I just love that, especially when the repair guy comes and does the same thing. It's like, oh, come on, people. Okay, so problem solving. Here are 4 things. These would be 4 good things to write down, too, by the way. 4 questions to remember anytime you're solving a problem. And they're also on the sheet that was handed out. So anytime you get a science project or a math problem, what is the problem? Okay, you need to clearly understand what the problem is. What is your plan to solve the problem? How will you implement your plan? And when you're done, how did you do? Go ahead.
So you're mostly going to create a plan of how's it going to work, right?
Correct. Yep. So when you develop the plan, you have to know what you want to do and how it's going to work. That's exactly right. And then when you're all done, number 4 there is, how'd you do? Are things better? What grade did I get? That's another way of determining how well you did. Alright? And the more problems you solve, the better you will be at solving problems the next time. So what is the problem? When you understand the problem, you put the problem in your own words, or you can use pictures and diagrams to help you understand the problem. You build a flow chart or a rubric. I know the teachers hand out a rubric, and it'll tell you what you need to have done, to organize your thoughts. That's a helpful tool when you solve problems. I don't know if you remember, I had that drawing that looked real complicated. Every time I start a project, I make a drawing like that. Do you have enough information to solve the problem? You ask questions. Your science teacher hands out a project, and you don't understand it. You ask them. You ask them questions. That's important. Ask questions. Teachers love to answer questions.
They do?
Yes. Number 2, you figure out a plan. And in order to help you do that, you can draw a picture. Try to solve a simpler problem, work backwards from where you want to end up and where you are. The main thing is be creative and use your head, use your noggin and think. Okay, so on the paper, create a plan. That's exactly what we're talking about here. So what is on step 2, what's the first step? You guys know what an algorithm is?
Yeah.
What's an algorithm? No? Go ahead.
Your algorithm is the steps, like a procedure that you have to approve.
You got it. You're exactly right.
It's like the procedure that you have to use for it's like the code you have to use for the code.
That's right. An algorithm is a procedure or a code that you need, that you're going to use to solve a particular problem. Alright? As we go on the list, draw a picture, just like you say there. Try working backwards. Solve a problem one piece at a time. Also compare a puzzle to something you've done before in the past. Okay? So let's look at step 3. Who wants to read what is the first one?
Do you solve the puzzle?
Okay, yeah, that's right. And if you didn't solve the puzzle, what does it say? If you don't get the puzzle right, what do you do next?
Hunt for one error is out.
That's right. Step by step, you maybe work backwards and try to figure out what you did wrong. Okay? I've seen the programming that you guys do with the bees and the nectar. If I've seen it, I know you've seen it. And the way to troubleshoot that is one step at a time. And maybe write down on a piece of paper. Draw a little diagram of what you're doing. What about the next one under step 3?
Retest your plan after every change.
Okay, what about the next one?
If you start to get frustrated, take a deep breath or leave your screen for a minute. When you come back, you may see what was causing the problem.
That's right. You'd be surprised how often if you just get up from the computer and walk away and come back, how suddenly the solution pops into your head. Does that ever happen to you guys? Happens to me all the time. I'll be working late at night trying to figure out a problem, and I'll say, I can't figure this out. I'll just go back to the hotel if I'm out of town. And I'll come back the next day, and there it is. The answer was there. It just popped into my head. Okay? All right, let's go to number 4. What's the first? Anyone want to read the first one? Go ahead.
Your answers off the puzzle.
Okay, that's easy enough, right? Especially with programming, because you know if the bee doesn't get the nectar, it gives you an error, right? You know right away it's wrong. All right. What about the next one? The next comment? Yes.
Did you hit all the goals of this puzzle?
That's right. Okay, so not so much in the coding class, but what about on your science project? How do you know if you hit all the goals or not? What's that? I'm sorry, I didn't hear you. You what? Oh, I didn't hear you. Go ahead, yeah? That's right. Well, on the science project, how do you know if you did everything right? Your grades, right? You have your customer is your teacher. I have customers with the companies I work for. Your customer is a teacher. He or she's grading you on your work. That'll tell you if you're hitting all the goals you're supposed to hit. What about the last one there? Could you explain your solution to help? So I think if you read through these 4 steps, that'll help you a lot with your programming. It'll help you in all your other classes too. Yes? Go ahead. Yeah, you can.
Now that you have one way to solve the puzzle, it's the easier to do it.
That's a good point. Yeah. That's really important because, and I see it with the people I work with. Someone will solve a problem, but their answer is so difficult and hard to understand that it's not very helpful. So not only is it important to solve the problem, but it's important to do it in as straightforward and uncomplicated way as you can. Does that make sense? So that's what they're saying there. That's really important. Anything else on these 4 steps? Very important. One last thing I'd like to point out. By the way, thank you for the 3D bulldog. I wanted one of those. One thing I want to point out is this whole idea of understanding the problem and formulating a plan, but mostly understanding a problem. There's stories about people who do go to contests on writing computer programs. We'll give them a problem and they have to write a program to solve whatever problem they're given. There's stories where they're given like 2 hours to do it, and some people just start programming like madmen right away. Okay, they're just typing away. But there's stories about other people who just sit there and think about the problem, and think about how they can write a program that's very straightforward and uncomplicated. And then in the last 10 minutes, then they write their program. Okay, so what does that mean? What's important about problem solving, writing, and programming is that first step. Understand the problem and think it through completely, and make sure you understand what you're trying to do before you even start. All right, any questions? You guys, you had to write down 3 things. Do you want to ask me again, or anyone? Yes.
What do you have to do to get to where you're going to go, or to get to your
What degree to get?
On some of my problems, like in my job? Okay, good. That's a really good question. Because a lot of times, a company will hire me, and they don't really know what they want. They know kind of what they want to do, but I can help them define on this particular machine that makes gasoline. Okay? So I'll say, okay, I'll say, how much do you want to make? How much do you want to make, and how much energy do you want to use? Okay, so I formulate the problem right away. The next thing I do is usually I'll draw that picture so I have it clear in my mind. Where I work, these processes are really difficult. They're really confusing. So I'll draw a picture. When I draw a picture, then I understand the problem a lot better. Okay, and we spend a lot of time, like 30 to 40% of the project, just formulating the problem. Once we have that, then we build a controller from there. Does that answer your question? Yes.
Do you know like some of the problems they sometimes they can't remove?
Really? Yeah. Hard problems? What are some hard problems? I don't know. The question was, he asked me what are some hard problems that when I was confronted with a problem where I thought this is really hard, I can't do it, or I don't know how to solve this problem. Okay, so a good example of that is I've within our company the type of work I like to do is I like to put controllers on a process that no one's done before. All right, so I'll show up at the customer at the plant, and they'll tell me this process makes bulldogs. I said, well, I've never put a controller on that makes bulldogs, but after understanding the problem better and figuring it out, little by little learning, I'm able to build a controller that makes better bulldogs. Okay? So to answer your question, anytime I get a process that I've never done before, or I build a controller that I've never built, I always wonder if I can do it or not. But you can always figure out a way. Good question.